equivalent statements and variations of conditional statements. These are the objective. Use a truth table to show that statements are equivalent. Write the contrapositive for a conditional statement. Write the converse and inverse of a conditional statement. So two statements are equivalent. If a compound statement is true, then its equivalent statement must also be true. If a compound statement is false, then its equivalent statement must also be false. Okay. So let's look at one equivalent statement. Let's say a compound statement, which is conditional statement P implies Q. The equivalent of this statement is not Q implies not P. They are equivalent. So their truth table, truth value is supposed to be same. And this is also called contrapositive. The truth value of a conditional statement does not change if the antecedent and consequent are reversed. Look at here, we reverse. And both are negated. So we reverse it and negated it. So the statement negation of Q implies negation of P is called the contrapositive of the condition P implies Q. So conditional P implies Q. Converse of that is Q implies P. Inverse of that is not P implies not Q, and contrapositive of this statement is not Q implies not P. So based on this fact, let's do some examples. Fill in the blank so that the resulting statement is true. The contrapositive of, we can use this table here, the contrapositive of P implies Q is not Q implies not P. Not Q implies not P. Let's see. If a conditional statement is true, its inverse must be false. Its inverse must be false. So conditional statement is this, its inverse is this. So P implies Q, not P implies not Q. That's not true, because even not P could implies Q. So this is not true. Okay, we don't know, because they are not equivalent statement. The only equivalent statement is this one and its contrapositive. So but conditional statement is true, it does not mean that the inverse is false. So this is false, because if a conditional statement is true, its inverse can be true, not false. We don't know for sure. Okay, let's fill out this truth table. Use a truth table to show that negation of P or Q and negation of Q implies negation of P are equivalent. We would like to show that these two are equivalent by showing their truth table. Keep in mind, two compound statements are equivalent if their truth values are same. So if P is true, Q is true, then negation supposed to be false and false. Then negation of P or Q is true, because one of them is true. And then negation of Q implies negation of P. So as long as negation of Q is false, it's always true. Keep in mind, the conditional statement is always true, except the truth statement implies the false one. But here it's a false implies the false one. Okay, true, false. So that's supposed to be false, true, opposite. And or means negation of P or Q, because both of them are false, it's supposed to be false. Now negation of Q, which is true, implies false, so that's supposed to be false. This is the only case where conditional statement is false. Negation of P is true, negation of Q is false, because they are opposite of these two. and negation of P, which is true or Q, true or true is true, and then false implies true, it's always true except the second case. Negation of P is true, negation of Q is also true, true or false is false, true or false is true, sorry, it's always true except both of them are false. And then here negation of Q, which is true, implies true, that means it's true. Okay, which statement below is equivalent to the given statement? So this is the statement: it is not raining or something is wet. So it is not raining, let's say P is it's raining, and something is wet. So negation of P is it is not raining or something is wet. So the equivalent statement supposed to be this one, which is nothing is wet, something is wet, negation of that is nothing is wet. If nothing is wet, then it's not raining. Okay, so if Q is something is wet and not P is nothing is it's not raining. So if nothing is wet, then it's not raining. Okay, these are the equivalent statement. Write the converse, inverse and contrapositive. We can use the help of this. If it is time to go, let's say P, then it is 4 o'clock. Okay, converse of that is just flip it. So if it's 4 o'clock, then it's time to go. If it's 4 o'clock, then it's time to go. That's a converse. And inverse means, look at here, inverse means it's not P implies not Q. So if it's not time to go, then it's not 4 o'clock. If it's not time to go, then it's not 4 o'clock. That's the inverse. Contrapositive, as you can see here, just flip it and negate it. Negation of Q implies negation of P. So if it's not 4 o'clock, then it's not time to go. If it's not 4 o'clock, then it is not time to go. Okay, let me do one more question. Write the converse, inverse and contrapositive of the statement below. R implies negation of P. So converse means you just have to flip it. So negation of P implies R. That's the converse. And then inverse means you just have to take the negation of this statement. So negation of R implies negation of P, which is P itself. That's the inverse. Contrapositive is you flip it and then you negate it. So P implies negation of R. P implies negation of R. That's the contrapositive. And that's all for this section.